Invisible to the naked eye and infrared sensors, it is the ultimate predator. Capable of penetrating the most hardened air defenses to strike high-value targets. The dream of the flying wing began decades ago with Jack Northrop's vision. Precision is measured in microns. Every layer adds to the bomber's strength. Under immense heat and pressure, the wing is baked into a single, seamless piece. The B-2 can carry 16 of these precision-guided ghosts. Finally, the radar absorbent material, or RAM, is applied, a secret chemical cocktail. Every gap must be filled. Even a loose screw can reflect radar like a lighthouse. Ready for the deep strike. The $2 billion ghost is born. The wing-to-body join is the most critical structural point of the flying wing. To hide from infrared, the engines are buried deep within the wing, shielded by heat-dissipating ceramics. No afterburners are used. The goal is a cool, quiet exhaust. The S-shape traps radar waves, never allowing them to reach the engine face.
Intake flush, locking alignment.
Every control surface must move without creating a radar-reflective edge.
Smooth integration, no gaps.
Yaw is controlled by drag, not lift, a design masterclass in stealth. Quadruple redundant fly-by-wire. The computers keep the ghost stable. Four advanced multifunction displays replace dozens of analog gauges, providing a streamlined glass cockpit interface. The B-2 is the first aircraft to use a side stick controller for yaw and pitch, integrated into this unique yoke. The ACES-2 ejection system provides zero-zero capability, allowing the crew to safely escape even at zero altitude and speed. Tightening primary seat bolts to spec. Applying torque stripe for verification. Connecting initiators, testing continuity. First connection secure, checking next. All circuits operational. The advanced crew life support system includes an independently redundant oxygen supply for high-altitude missions. Encrypted satellite communications and a secure intra-flight data link are vital for coordinating complex missions. Independent inertial and GPS navigation ensure the Spirit can find its target even in a GPS-denied environment.
Connecting master caution panel. Initiating lamp test. Test complete.
This specialized coating is the final layer of defense, making the complex shapes around the cockpit invisible to radar. Even robotic application requires a skilled human hand to ensure perfection at every critical boundary. These ceramic tiles provide the final, gapless radar scattering on the aircraft's most exposed edge. bladders are designed to expand and contract with the aircraft's thermal changes during high-altitude flight. Redundant pumps ensure fuel continues to flow even if the aircraft is inverted or under high G loads. Safety is paramount. Every electrical connection is shielded against sparks and static discharge. Before a drop of fuel enters, the system is pressurized with nitrogen to check for the slightest leak. The refueling door is flush to the skin, rotating only when the Spirit needs to drink from a tanker. This system doesn't just keep the pilots warm, it cools the sensitive radar electronics. Waste heat is mixed with cold atmospheric air to mask the thermal signature. Forged from high-strength titanium, these struts must absorb the impact of a heavyweight landing. The connection must be perfect. There is no room for play in the landing gear geometry. Each main gear features 4 wheels to distribute the massive weight across the runway. Retraction must be rapid to quickly pull the gear into the radar-shielded bays. The doors use the same sawtooth design as the tail, ensuring radar waves are scattered away. Conductive seals bridge the gap between the door and the wing, preventing radar from leaking into the cavity. The nose gear provides the steering, allowing the Spirit to navigate tight taxiways. Before the launcher is loaded, the bay must be perfectly squared. This rotary launcher allows the B-2 to cycle through different munitions in seconds. Total weight of the launcher and missiles can exceed 20,000 pounds per bay. Smart bombs are the Spirit's primary tool for surgical strikes. Reliability is tested thousands of times. The launcher must cycle perfectly every time. The outer mold line must be accurate to within the thickness of a human hair. Any deviation in the surface can create a bright spot on an enemy radar screen. Blade seals are conductive, ensuring the entire aircraft acts as a single electrical entity. Every seam is hand-finished to ensure a perfectly aerodynamic and stealthy transition. The leading edges are hollow, filled with a honeycomb structure that traps and dissipates radar energy. This cap is made of specialized radar absorbent structure, or RAS. Fasteners are hidden deep inside to avoid creating any external metal reflections. Before the final gray coat, a conductive primer is applied to bond the ram to the graphite skin. Thickness is controlled to within 1/1000th of an inch.
The direction of the carbon fibers themselves is aligned to minimize radar return.
The splitter plate separates the slow-moving boundary layer air from the high-speed air the engines need. This paste rounds out sharp edges, which are primary sources of radar glint. The ram paste is heat-cured to ensure it becomes part of the aircraft's permanent structure. The exhaust shelf must withstand extreme temperatures while remaining cold to infrared sensors. Air is pumped between the tiles to keep the surface temperature invisible to heat-seeking missiles. The glass is embedded with a microscopic gold mesh that reflects radar waves away from the cockpit interior. Every bolt must be flush to maintain the stealth profile. No protruding probes are used. Airspeed is measured through these flush-mounted ports. The ANAPQ-181 radar uses LPI technology, low probability of intercept. Modular avionics allow for rapid upgrades as electronic warfare evolves. Satellite links keep the crew connected to the Pentagon from anywhere on Earth. ESM sensors allow the B-2 to hear enemy radars without being seen. The mission map correlates radar data with satellite intelligence in real time. The digital ghost is now awake. Its software is its most powerful weapon. The outer wing panels are engineered as single-piece composite structures to eliminate radar-reflecting joints. The tolerance for the wing-to-body joint is 0. Even a microscopic burr of metal could compromise the structural life of the airframe. It is a 70-ton jigsaw puzzle played out in 3 dimensions. To ensure the perfect fit, the titanium spars are heated slightly, allowing them to expand and lock into the composite sleeves. This is the first of the master bolts, the anchors that will hold the wing under the stress of a 2G turn. We don't just screw them in, we pull them with 10 tons of force to create an interference fit. 64 high-strength titanium bolts secure each wing, torqued to over 1,000 foot-pounds. This conductive paste ensures that radar waves flow over the joint without creating a glint. We look through the skin to ensure the internal titanium bond is flawless. Without a vertical tail, these wingtip clamshells provide all the directional stability. The decathlon rudders split open to create drag, turning the aircraft without the need for a tail fin. Even when open, the internal edges must be radar absorbent to prevent detection during maneuvers. Static electricity can glow in the dark on radar. These wicks bleed it off into the atmosphere. Traditional pitot tubes are radar magnets. Instead, the Spirit uses dozens of flush-mounted pressure sensors to calculate airspeed and angle of attack. Fiber optics are immune to the electromagnetic interference of the Spirit's own jamming suites. Even the lights are stealthy. They retract into the wing during combat missions to maintain the perfectly smooth OML. Every single panel gap on the 170-foot aircraft is measured. Nothing over 0.1 millimeters is allowed. Even a microscopic ledge can catch a radar wave and send it back to the enemy. The skin must conduct electricity at a specific rate to properly dissipate radar energy. When the gear is up, the bay becomes a tomb. No radar can enter. The seal must be compressed by exactly 30% to create the required radar block. The aircraft now knows it is on the ground. Its computers transition from flight mode to taxi mode. Compressed air is used to spin the turbine blades to 20% RPM. Synthetic oil must reach every bearing in the 19-foot engine core. The blades must be perfectly balanced to avoid acoustic signatures that could tip off enemy sensors. 7,000 gallons are pumped in to check the center of gravity and seal integrity. Fuel contains a fluorescent dye. The slightest leak will glow bright green under UV light. These antennas are flush-mounted, wrapped in radar-transparent materials. Light-speed data transmission ensures the jammer reacts faster than the enemy's missile guidance. The pilot is alerted to any radar search within a 300-mile radius. If stealth fails, the Spirit deploys clouds of radar-reflecting glass fibers to blind incoming missiles. Even the defensive doors must maintain the aircraft's $2 billion silhouette. The exhaust is channeled over a wide, flat shelf to cool the gases before they leave the aircraft. These tiles are similar to those used on the space shuttle, capable of withstanding 1,200 degrees. Tolerance is 0. A loose tile could cause the wing to melt from the inside out. Cool atmospheric air is sucked in through these vents to mix with the hot engine exhaust. The slightest speck of dust can compromise the stealth integrity. This paint contains iron ball particles that convert radar waves into harmless heat. One layer, uniform, perfect, applied at a constant temperature of 72 degrees. Each of the 21 bombers is named after a U.S. state, a unique identity for a billion-dollar asset. The surface must be matte. Gloss reflects light. Light reveals the ghost. The anechoic chamber is an electromagnetic void. No radio waves can enter, and none can escape. To test stealth from every angle, we must rotate the entire 160,000-pound bomber with precision. We bombard the aircraft with frequencies ranging from UHF to X-band, simulating every known enemy radar. On radar, this $2 billion bomber appears no larger than a common honeybee. The gold mesh glass must reflect the waves away, preventing them from entering the cockpit cavity. With the doors open, the B-2 is briefly visible. We measure exactly how much leakage occurs during a bomb drop. Speed is safety. The faster the doors close, the sooner the ghost disappears again. Even at full power, the exhaust temperature must remain lower than the surrounding air. Secondary air is the secret to the cold exhaust. It dilutes the heat before it ever leaves the wing. Stealth isn't just about what the radar sees. It's about what the ground hears. The S-duct intakes baffle the sound, trapping the roar of the engines inside the wing. The Spirit's brain must be hardened against the massive electromagnetic pulse of a nuclear blast. Redundant shielding ensures the fly-by-wire system never flinches, even in the heart of an electronic storm. Tempest testing ensures no stray radio signals leak from the internal computers to the outside world. The final flight software is loaded, the code that allows the B-2 to fly its unstable frame with grace. In a flying wing, balance is everything. A fraction of an inch could cause a stall.
We simulate a total failure of the primary computer. The secondary must take over in milliseconds.
The final touch. A clean surface is a stealthy surface. The manufacturing is complete. The aircraft is now mission ready. The Ghost leaves the shadows. Its next stop, the flight line. 21,000 inspections, every one of them passed. Built for the deep strike, born for the silence. The transition from machine to warfighter is complete. The final scene of the factory is the first scene of the mission. Starting the 4 General Electric F-118s is a choreographed sequence of air, fuel, and spark. The non-afterburning engines are designed for subsonic efficiency and a whisper-quiet acoustic footprint. At idle, the Spirit is quieter than a commercial airliner, a ghost even in the acoustic spectrum. The last physical connection to the Earth is severed. 160,000 pounds of stealth begin their journey to the active runway. Steering a flying wing requires precise fly-by-wire coordination of the nose wheel and the split rudders. The last chance inspection ensures no fasteners have loosened during the taxi vibrations.
Confirmed. Logging it.
From the front, the Spirit's cross-section is virtually invisible to the naked eye. Full military power, no afterburners, pure efficient force. Rotate. The Spirit reaches for its natural habitat, the high-altitude void. Positive rate. Gear up. The Ghost is now fully sealed. The radar-reflecting cavities are gone. Cruising at 50,000 feet, far above the reach of most conventional defenses. To the world, it is a mystery. To the pilot, it is the ultimate shield. Mission success is not just about the strike. It's about the return. Built by tens of thousands, flown by a select few, the B-2 Spirit. Precision, stealth, spirit.